multiply those polynomials that we added, subtracted, and classified yesterday. To be honest, you really know most of these techniques. I just want to make sure that we write them down, and I'd like to introduce you to a couple new ones. The first type is when we have a monomial times a polynomial. The technique that's most used in this case is distribution. Let's take a look at 3x squared times x cubed plus 4. When we distribute in, we're going to get 3x to the fifth plus 12x squared. Another type is when we multiply a binomial times a binomial, or do a 2 by 2. This is when you FOIL. And you already showed me that you know how to do that with I, so I'm pretty sure you'll be good with x. But let's look at an example anyway. When I FOIL this one, I'm going to have 2x squared minus 6x plus x minus 3. Don't forget to combine your like terms in the middle for 2x squared minus 5x minus 3. Now for the new one. This is when we have a polynomial times a polynomial, so it'll be more than 2. The method that I prefer to use is called distribute and shift. Really, this method just organizes our information. You'll see this in our first example, 3x minus 2 times 3x squared minus x minus 2. I'm first going to distribute that 3x. Then I will distribute the negative 2. But notice that when I write down the distribution, I shift down and in. This way, my exponents line up in columns. So then all I have to do is combine like terms. It just makes our work nice and tidy. Let's try it again with a bigger one. This time I'm going to do a 3 by 3, but the procedure is exactly the same. So let's take a look at x squared. I'm going to multiply that into the trinomial behind. Then when I multiply 3x, I'm going to shift down and in. Notice how those exponents are matching up. Then we're going to do it one more time. Shift down and in. My exponents are still matching up. So now when I combine like terms, I can feel confident that they are in the columns. It really just organizes all of the good multiplication you know how to do. Now let's take a look at Pascal's triangle. Pascal's triangle is a way for us to expand binomials quickly. Sometimes we'll have these binomials like x plus 2 to the power of 5, 6, or even 9, and this will help us do it fast. But first, we need to figure out how. We're going to start off with a triangle of 1s. Then in our third tier, we start with a 1 and then add the 2 numbers in the middle, and then end with the 1. Then start it over again. So the next one is 1, 3, 3, 1. Then 1, 4, 6, 4, 1. One more time. 1, 5, 10, 10, 5, 1. Now let's label these tiers, okay? The tiers are going to be labeled based off of the power. The one at the very, very top is actually going to be tier 0. Then we're going to go down. So we've got 0, 1, 2, 3, 4, 5, and it could continue. What I want to highlight to you is that the power matches the second number in the line. So take a look at this. 2 matches to 2, 3 matches to 3, and so on. This is not an accident. It'll actually help you make sure you have the right tier. Now let's see how it works. For our first example, what I want to consider is x plus 2 to the 4th power. The power is going to tell me which tier to use. So I want to use the one with the 4, or where the second number is 4. So I'm going to use the numbers 1, 4, 6, 4, 1. The next element I need to look at is the first term in the binomial, which is x. Then I need my exponent, which is 4. I'm going to write the x's underneath the numbers I just wrote, and my exponents are going to go in descending order. 4, 3, 2, 1, 0. Then I'm going to do the same thing with the 2, but I'm going to start from the back. 2 to the 4th, 2 cubed, 2 squared, 2 to the 1st, 2 to the 0. Now from here, we're going to have to multiply. Keep in mind that anything to the 0 power is just 1, so you'll notice that I just crossed those off. Now we're going to multiply in the column. Be careful when you multiply that you do exponents first when it applies. So when we multiply in these columns, I'm going to have x to the 4th in the first column, 8x cubed in the second, 24x squared in the third, 32x in the fourth, and my constant is 16. Since there's a plus sign in the center of this binomial, that just means that all of my signs are positive. I think we need to do that a couple more times. Let's take a look at another example. This time, let's consider x minus, what am I going to choose? 3. We'll do this one to the third power. So the third power, there we go. So I'm going to have 1, 3, 3, 1. That's how I'm going to start. Then I'm going to consider the first part of my binomial, which is x, and do my exponents in descending order, starting with the one given in the problem. So 3, 2, 1, 0. Then I'm going to do the same thing with 3, starting from the back. 3 cubed, 3 squared, 3 to the first, 3 to the 0 power. Let's scroll up so I have a bit room. Don't forget, 0 powers cancel, so I just like to cross them out. However, when you multiply, it is very important that you do exponents first. So let's see how you do. X cubed, 9x, 27x, and then 27. This one has something that's a little bit different though. There's a minus. This time, my signs will change. Plus, minus, plus. Let's try one more. This time, we are going to have 2x minus 3, and I'll do the third power again. This one's going to have something new as well. We are still going to start off with the tiers, so I'm going to have 1, 3, 3, 1, just like I did with the other problem. Now notice how this binomial has 2 terms in its first spot. I'm going to write them separately. So I'm going to take my 2 first. So I've got 2 cubed, 2 squared, 2 to the first, 2 to the 0. Now I'm going to do it again with x. X cubed, x squared, x to the first, x to the 0. Now we're going to go to the 3. 3 cubed, 3 squared, 3 to the first, 3 to the 0. Don't forget, zeros cancel. This is a really good place to pause the video and multiply it yourself to see how you do. Then play to see if it matches. When I multiply all of these numbers out, I've got 8x cubed, 36x squared, 54x, and 27. Now this one has a minus in the middle, so we're going to start with a plus sign, and our signs will alternate, plus, minus, plus. Now let's practice.